Hi everyone, in this lecture we are going to iterate over arrays. So we have imported NumPy and we have the array np.array range, and there are 10 elements within this array, and each of them is raised to the power of 2. Now how can we, this is a one-dimensional array obviously, how can we iterate over a one-dimensional array? It is easy. Iterating over one-dimensional arrays is extremely easy. We just say for element in A, what do we want to do? Let's just print the element. So I'm going to say, you know what, I'm going to do something with that. I'm going to say element, grab each element, and then you know what, raise it to the power of 1 by 2. If I run this, there we go. So we end up again with 1, 2, 3, 4, 5, 6, all the way to 10. Let's take a look at our students array from the previous lecture that we had. So here we have names, then some scores, and also some other numbers. Now, whenever we want to iterate over the first dimension of the array, every row is going to be selected. So if I say, I'm going to say for I this time in students, I'm going to say print I, okay, print I. Let's just grab the loop variable. There we go. So whenever you're trying to iterate over a two-dimensional array, the first iteration is going to happen on the rows. So I should have probably taken a look at this first. There we go. So we got this row, as well as this one. All of them are printed separately. Now iterating over every element of an array can be done very easily using the flatten method. So we are going to say for I in students dot flatten. Let's just print I. By default, flatten method is set to row major flattening. It means that all the values in the rows, they're going to appear next to each other. It means that the first values you're going to see are going to be as follows: John, Jack, Julie, Joanna, then 59, 78, 89, 99, then 15, 84, 54, 32. This is row major flattening. There we go. So all the values in the rows, they're appearing together. But if you wanna change this from row major flattening to column major flattening, you need to provide an order equal to f argument, and this is gonna provide it in the column. So we are gonna have John 59, 15, Jack 78, 84, John 59, 15, Jack 78, 84. All the columns values, they appear next to each other. Let's create a multi-dimensional array. I'm going to say x is going to be equal to np.arange 12. Let's reshape it to an array of 3 by 4. Let's take a look at x. Here is our array. Now, we do have another method that is called nditer, which is going to iterate over our array multi-dimensional arrays as well. So we are going to say for I, I'm just going to say I in np.iter, np.nditer, and now provide the name of the array, which is x. What do we want to do with that? Basically, let's just go ahead and print the loop variable. By default, nditer is going to be row major flattening, the same way with the flatten. All the rows values, they're going to appear next to each other. If you want to change this behavior, you are going to have to provide another argument in here, which is going to be the same as that, the other function, the flatten function. Now all the columns appear together. 0, 4, 8, 1, 5, 9. 0, 4, 8, 1, 5, 9, 2, 6, 10, 3, 7, 11. The difference between the flatten and the nditer is that flatten method actually returns a result array. Nditer just allows you to iterate over the elements. Now let's say you want the innermost dimension of your loop to be expressed as a vector or as a single dimensional array. You want to iterate over all the outer dimensions. Every column is expressed as a 1D array, so the innermost dimension is expressed as a vector or a 1D array. So how can we do that? Basically, we are going to say for I in np.nditer. What do we want to do? We want to iterate over the X array. The order is going to be along column major flattening, and we are going to provide flags. So the flags, they're going to specify external loop, external underscore loop. Now in this case, every column is going to be expressed as a one-dimensional array, and the innermost dimension is going to be expressed as a vector. Let's say we want to just print I. Just print that. So all the columns, what is this? Let me just print X itself. So we have, you can see all the columns, they're printed as a one-dimensional array, right? So this is 048, this is one array. 159, this is another array. 2610, this is another array. And 3711, that is another one-dimensional array. Now, when you use the nditer function for iteration, keep in mind that the nditer function is read-only iteration. You cannot assign to elements in your array by default, of course. There is a work around it, but by default you cannot do that. So if I say for item in np.nditer, pass in X. If I say array, let's pass in the ellipsis. The ellipsis is going to refer to every current item that is in the process of getting iterated over. And we want to change that to array times array. If I run that, it says name array is not defined. Have we not defined? Oh, oops, this is item. So all of these have to be array. Let's run that. Assignment destination is read only. This one. See, this is read only. How can you change this property? So the way that you can change this just to avoid getting this error is provide another argument, and that is op flags. This is going to be another list. Just say read write, and now when you run it, you're going to end up with nothing. Okay, nditer. So we have changed something. Now let's take a look at X. There we go. So what does this mean? It means that all the items within the array, they have been multiplied by themselves. So if we take a look at the original X, it is 0. 0 multiplied by 0, we're going to get 0. 4 multiplied by 4, 16. 8 multiplied by 8, 64. 10, in this case, multiplied by 10, 100. 11 multiplied by 1, 11, 1 to 1. With this, our lecture comes to an end. See you in the next one.